CSEC Multiple Choice Practice Paper 6, Part D will take us to the end of this practice paper. We will now solve all of the problems beginning at number 46 and ending at number 60. Which of the following represents the equation of a straight line? The equation of a straight line has the general form, and there we have the general form of the equation of a straight line. That general form is y is equal to mx plus c. The equation in the options that has that same form is the equation of a straight line. We are going to take a look at the options. The equation, the single one that is in this set of expressions, which of course are equations, the one that is in the same form as this one is the correct one. The one whose form matches the general form of the equation of a straight line is option B. Option B matches the form. We have y is equal to 2x minus 3. Here we have the general form of the equation of a straight line that we have right here, and we are comparing it with the form that we have in option A. The form of option A does not match because it has a single term. Notice that we have y is equal to, here we have one term and another term. Now we have y is equal to 4 over x, just a single term. So we have a single term, while in the general form we have two terms. Furthermore, in this form we have x in the denominator of the fraction. Therefore, it does not match with the equation of a straight line, y is equal to mx plus c. Now we are comparing the general form with the equation that we have in option C. The form of option C does not match because of the x squared on the right hand side. So whereas we have m times x, on this right hand side we have x squared. So we know that there's no match between the two equations. There we have the comparison between the general form of the equation of a straight line and the equation of option D. Option D has only a single term on the right hand side. It does not match. In the general form of the equation of a straight line, m and c are real numbers. M is the gradient and c is the y-intercept. And the y-intercept is that point where the line crosses the y-axis. The lengths of 30 cabbage leaves were measured to the nearest centimeter, and the information grouped as shown in the table. The class boundaries are, that is what we need to determine. We need to determine the class boundaries. Students who are familiar with boundaries and their calculations will not even take a second look at the problem before selecting D as the correct answer. There you have it, option D is correct. They know that boundaries are usually the averages of two consecutive integers. Each answer should therefore be followed by 0.5. The only option that has this is option D. I think that you could probably do an experiment on your own. Add any two consecutive integers and you will realize that the answer will have 0.5 or a 0.5 at the end when divided by 2? Because the class boundaries are usually averages of 2 consecutive integers, then we know that we will have 0.5 at the end of each one of them. The only one, or the only option that has 0.5 or the 0.5 at the end of each one is option D. And that is if you are familiar with the calculation of class boundaries. We will no doubt take a look at this under the microscope to verify our answer. A boundary is a common point between 2 entities. In statistics, it is a common point between 2 classes. The first class ends at 14 and the second begins at 15. What is the most appropriate number that may be common to both classes that will mark where the first ends and the second begins? What do we have here? We are highlighting 14 and 15. Then we have 14 plus 15 divided by 2. The average of the 2, that is what we are determining. We are determining the average of the upper limit of the first class and the lower limit of the second class. That turns out to be 14.5. We will take the average again. The next boundary will be the average of the upper limit of the second class and the lower limit of the third class. Two of the boundaries are enough. There is no other option apart from D that has those values. It is therefore correct. However, we will take a look at some more statistics on the next slide. More statistics. I am sure that we can already see that there is a pattern that we may use to write down the other boundaries. But it is not good to come to a conclusion about a sequence by using only 2 terms. Well, we have 14.5, 19.5. We will just add another, because the difference between these two is 5. We'll just add another 5 to this, and we will get 24.5. But in mathematics, it is not usually a good idea to come to a conclusion based on only 2 terms of a sequence. Let us do another one. Let us find the next boundary by calculating the average of the upper limit of the third class and the lower limit of the fourth class. By taking the average again, we get 24.5 as we imagined. The pattern is clear. The difference between consecutive boundaries is 5 units. The upper boundary of the last class may be found by adding 5 to 24.5 because we are increasing by 5. Add 5 to this one and we will get the other one. And the lower boundary of the first class may be found by subtracting 5 from 14.5. So if we are going up 19.5, 24.5, we add another 5. If we are going down 24.5, 19.5, 14.5, we subtract another 5. And that is how we arrive at this one. We imagine that we have a sequence continuing like that. And the upper one will be found by just adding 5 to this one. The numbers on which the classes are defined are called limits. The smaller values are the lower class limits, and the larger ones are the upper class limits. So here we have the lower class limits, the numbers that the classes are defined on. Then we have the upper class limits, the larger numbers that each class is defined on. The common number between two classes is called a boundary. We calculated the boundaries on the previous slides. The upper boundary of the particular class is the lower boundary of the succeeding class. That is, the upper boundary of a particular class will be the lower boundary of the class that is coming after. And the lower boundary of the particular class is the upper boundary of the previous class. A class has two boundaries. The smaller number is called the lower class boundary, and the larger number is called the upper class boundary. There we have them. Lower class boundaries and upper class boundaries. Another statistical parameter that has to do with the class that we may find very useful is the width of the class interval, called the class width. Some may attempt to calculate it by using the class limits. It is, however, calculated by making use of the class boundaries. Sometimes in statistics, you might have a problem saying, find or determine or what is the width of the class interval. Students just jump straight ahead and they subtract the lower class limit from the upper class limit. That is not to be done. We will find the width of the class interval by subtracting the lower class boundary from the upper class boundary. The width of the class interval is equal to the difference between the two class boundaries, not the limits. So we take any two, subtract one from the other, and we get 5. The width of the class interval is 5. One might ask, why not define the class on the boundaries since they have so many applications? Well, let us say that we are measuring small organisms to the nearest millimeter. Not every measurement will be an exact number of millimeters. Yet still, the additional fractions are not easily determined. So, if we are measuring the length of some small organisms to the nearest millimeter, when we put our ruler down, sometimes we might get a little bit over, sometimes somewhat beyond half, sometimes a little less than half of a millimeter. Right. What we do in these particular cases, we will just round off to the nearest millimeter. Right? So we will round to the nearest millimeter because not every measurement will be an exact number of millimeters. Yet still, the additional fractions are not easily determined. Each value will therefore have to be rounded to the nearest millimeter. Each limit will therefore have to be a whole number of millimeters. The same is not true for the boundaries. Therefore, the classes are not defined on them. Therefore, the classes are not defined on the boundaries. They are not defined on the boundaries because when you measure, you are not going to get a precise number of millimeters. You will get in between sometimes. Because of this, you will have to do some rounding off. And when you round off, you are rounding off to a specific number of millimeters. That is why we have to have that specific number of millimeters represented in the limits on which the classes are defined. Boundaries are used in organizing histograms and cumulative frequency curves. and the width of the class interval is used in the calculation of the mode and median. So those are some of the uses of some of the parameters. Which of the following relations is a function? It is not often that we see relations expressed with the arrows going from right to left. This should not prevent us from solving the problem. The principles are the same. All this means is that the domain is on the right hand side and the codomain is on the left hand side this time around. Here we will have the domain and we will have the codomain here. Only that is different. Well, we imagine that the arrows will go from the domain to the codomain. So it's just a matter of rearranging, just looking from the other side. Besides, we are accustomed to qualifying a relation as a function that has an inverse, which requires the ability to assess the reverse mapping even without the arrows going in the reverse direction, and is actually more difficult than what is required of this problem. This problem requires that we go in the direction of the arrow. That is all we need to do. The arrows are going in this direction. That is what we need to do. But when we are assessing a mapping to be a function with an inverse or not, we will have to consider the reverse mapping without the arrows going in the reverse direction, which is much more difficult than what we are doing right here, because we are going in the same direction of all of the arrows. There is no difficulty with that. So A, B, and C are not functions. A, B, and C are not functions because 2 in A and C and 3 in B are mapped to more than one element. There we have it again. 2 is mapped to 2 elements, 3 is mapped to 2 elements, and 2 is mapped to 2 elements. Therefore, we have A, B, and C are not functions. A and C are not functions for an additional reason. What is that reason? In options A and C, there is an element in each domain that does not have an image. They are out on 2 occasions. Sin has been added to sin. So, C and A are out on 2 counts because we have elements that are not mapped and we have a single element that is mapped to 2 others. A function is a mapping from one set called the domain to the other set called the codomain in such a way that each element in the first can only have one image in the second. The only mapping that satisfies this requirement is option D. The arrow diagram shows a function. Which of the following best describes the function? Which of the options best describe the function? There we are highlighting the expression of option A. The first expression is obviously correct. The function is operating on x by adding 3 to x in order to give the value of y. F of x is equal to x plus 3. We add 3 to the value of x and we get the value of y. And I'm saying that it is obviously correct. Let us add 3 to this, we get 5, and so on. Option A is correct. What about that one? This second statement cannot be correct. According to the direction of the arrows going from x to y, the function is not operating on y. Neither can there be a function of x with y in its algebraic representation. So we have y plus 3. Yet still, we are talking about f of x. This cannot be correct. In addition to that, if we add 3 to y all the time, we will not get the value of x. Probably we'll take a look at that in the next option. This statement of option C cannot be correct because there is no single case in which we add 3 to the value of y and the result is equal to the value of x. X is equal to y plus 3. If we add 3 to the value of y, 3 plus 5 is equal to 8. That's not the corresponding value of x. 8 plus 3 is equal to 11. That is not the corresponding value of x. Therefore, option C is incorrect. D cannot be correct because there is not a single case in which the values of y and x are equal. So the values of y and x are not equal in any single case that we have up here. Therefore, y is equal to x is not the correct option. We may go ahead and verify that option A is correct. We will do that by adding 3 to each value of x and see if this results in the corresponding value of y. Quickly, 2 plus 3 is equal to 5. 5 plus 3 is equal to 8. 8 plus 3 is equal to 11. 11 plus 3 is equal to 14. So we have it. In every single case, we add 3 to the value of x. The result will give the corresponding value of y. Option A is actually correct. What is the gradient of the line 2y plus 3x is equal to negative 8? What is the gradient of the line? I love questions like this. The equation of a straight line has the general form y is equal to mx plus c. In the general form of the equation of a straight line, m and c are real numbers. M is the gradient and C is the y-intercept. The y-intercept is where the line crosses the y-axis. Here we have y is equal to mx plus c. M is the gradient. C is the y-intercept. We will take the equation as given and transpose it to match the general form. That is our equation as given. We will transpose this in order to get it to match. We need to match this equation with this general form. Then we will make a further analysis. Subtract 3x from both sides. We need to eliminate this 3x from this side. We subtract 3x from this side. We need to subtract it from the other side also. This will result in 3x being eliminated from the left hand side, and on the right hand side we will have a negative 3x, like so. Usually when we are transposing, we will take this one. Since this one did not undergo any transposition, we will take this one and usually we put it at the back. We are putting it at the front this time in order that we might get it to match with the form. The value of x, the term in x goes first. We put the negative 3x first. Dividing both sides by 2 will result in 2 being eliminated from the left hand side. And on the right hand side, we will have what? 2 as the denominator. There we have it. Dividing both sides by 2 in order to eliminate this 2 from accompanying the y on the left hand side. The general form requires that we have y all by itself on that left hand side. Dividing each of the terms on the right hand side by 2 in order that the equation will match the general form. 3 is not divisible by 2. We will leave that as a vulgar fraction. 8 is divisible by 2, we may simplify that part. So what we will do is take this 2, divide into this, and take this 2, divide into this. In a short while, I will take a look at the common mistake that students make. And in addition to that, I will also take a look at the reason why by dividing this expression by 2, we will divide this term by 2 and this term by 2. We will take a look at why that is legitimate. So negative 3x divided by 2, we have it right here, and negative 8 divided by 2 is negative 4. We are leaving this vulgar fraction because the forms that we have here does not have any decimal. We will not resort to decimals. There we have our new expression. Let us remind ourselves of the general form of the equation of the straight line. Y is equal to mx plus c. That's the general form. As long as the equation of the straight line is written in that form, the coefficient of x is the gradient of the line. Now we have mx. M is the coefficient of x. Now we have negative 3x over 2. The coefficient of x is what? The coefficient of x on this occasion is negative 3 over 2. A lot of students sometimes, when they have negative 3x over 2, they consider the coefficient to be just this negative 3 alone. The answer is there for you. I do not know how they would consider the coefficient to be 2, as we have it right here. But I imagine that some of them might make that mistake, or at least consider that before they make some corrections to their answers. The coefficient of x is negative 3 over 2, as we have it right here. It is the gradient of the line, and the correct option is option B. Correct. One of the most common mistakes made by students in mathematics is the reduction of a fraction that contains a sum in the numerator by cancelling one of the terms with the denominator, as we shall see. Say we have this and we need to reduce this fraction. What we do is, this is how they would reduce by a common factor of 4. 4 into 4 is 1. 4 into 8 is 2. Therefore, we have the result 3x plus 1 over 2. Like what we have right there. Without applying any rule in mathematics, this has to be wrong, because why would you choose to reduce 4 rather than 3x? Here we have 3x plus 1. Well, we had before 3x plus 4. Why do we choose to reduce by a common factor of 4, saying 4 into 4 is 1, 4 into 8 is 2? Why didn't we opt to use this instead? Well, I imagine that because there's no common factor in these two, but that cannot cause the mathematical process to be legitimate. Then what would we do if we had a 2x right here? So we had a common factor. I guess we would have a little toss-up, a little rock and a hard place situation. Well, I imagine that most students might just look at the one and see the one that can be reduced by the common factor and just reduce that one and imagine that that can be correct. But that cannot be correct, because one has an equal chance of being reduced as the other. There's no genuine reason why one should be chosen above the other. It is also very important to know that when reducing fractions, we do so by taking a common factor. Therefore, if we cannot find a common factor between denominator and numerator, reduction is impossible. In reducing a fraction, we will have to have a common factor between numerator and denominator. If we cannot find that common factor, then we cannot reduce. If we want to reduce a fraction, we therefore have to find a common factor between numerator and denominator. If we cannot, as in the previous example, then we cannot reduce the fraction. This means that the number that we may reduce the fraction by has to be a factor of the terms in the numerator. And we will see what that means in a few seconds. If the number is a factor of the term in the numerator, we may factorize the numerator, then proceed to reduce the fraction by that common factor. There we have the fraction to be reduced. We have 6, 4. We have a common factor of 2 in the numerator. The numerator may be factorized by a common factor of 2. We are not reducing just yet. We are factorizing the numerator. So 2 into 6x is 3x. 2 into 4 is 2. We have factorized the numerator by a common factor of 2. We may now reduce by a common factor of 2. 2 into 2 is 1 and 2 into 8 is 4. 3x plus 2 over 4. The process is equivalent to reducing both terms in the numerator by the common factor. So we have 2 into 6 is 3 and 2 into 4 is 2. Then we say 2 into 8 is 4. We have 3x plus 2 over 4. Therefore, if we are reducing a fraction by a common factor, each term in the numerator has to be reduced by that common factor. In other words, we need to have a common factor in the numerator among the terms that we can reduce the fraction by. Instead of factorizing, we may reduce each term in the numerator by 2 as we just did. This is because we may only reduce a fraction by a factor that is common to all of the terms in the numerator. We may also find the common factor of the numerator, then reduce the fraction by that common factor. The processes are equivalent, but we need to know the reason. Why, when we have a sum like this in the numerator and we are reducing by a common factor, why do we reduce each one of the terms by the common factor? Why do we do that? We do that because in order to reduce this by a particular common factor, that number that we are using as a common factor has to be common to the two terms in the numerator. To the extent that we can factorize the numerator by using that as a common factor, then we may reduce. If not, then we may take each term and do the process that we have right here. We need to understand the reason why that can be done and also to avoid making the earlier mistake. From the graph, the values of x when y is equal to 1 are, let's take a look at this one. The values of x where f of x is equal to 0 are the points where f of x crosses the x-axis. The x-axis is the line on which f of x is equal to 0. we may say that f of x is taking the place of the y-axis. Y is equal to 0, therefore. The line that has equation y is equal to 0 is the x-axis. We need to find where the curve crosses the x-axis. That is, where this function is equal to 0. It is equal to 0 on the x-axis. What are the points on the x-axis? There we have them. The 2 points turn out to be x is equal to negative 1.75 and x is equal to 1.75, a positive 1.75 right there. The correct answer is option D. At first glance, the answers may appear to be negative 1.5 and 1.5. However, the answers are halfway between 1.5 and 2 on the negative side and between 1.5 and 2 on the positive side. So there is no danger in us arriving at negative 1.5 and 1.5. Just by glancing at it, a student may be operating on a speed, seeing a problem like this. Okay, we just know the answer. Between negative 1 and negative 2, let us put negative 1.5. Between 1 and 2, let us put 1.5. But if you look quite closely, you will realize that we have negative 1.5 here and 2 there. So 1.75 is where we are at. Here we have 1.5 and we have 2 here. It is between 1.5 and 2. 1.75 is correct. The largest prime number that is less than 100, what is that one? The largest prime number that is less than 100. Which one of these? A prime number is one that is divisible by itself and 1. That is, only itself and 1 can divide into it without leaving a remainder. That is a prime number. Divisible only by itself and 1. 91 and 97 appear to be prime numbers at first glance, but not for those people who had to learn their 13 times table. And I'm sure that we do not have anybody like this, because I did not have to learn my 13 times table when I was in primary school. Therefore, I do not imagine that anybody after my time had to learn their 13 time table. With the way how things are progressing these days, I am almost sure that there is no one who needs to learn any of the multiplication tables at all. It might be amazing to know that 91 is not a prime number, but it is not. 91 is not a prime number. 13 multiplied by 7 is equal to 91. 7 3 is 21. 7 1 7 plus that 2, we get 91. The examiners are very clever to make one of the numbers that appear to be a prime number the first option. I enjoy seeing problems like these, especially in a time like this when most students do not know their multiplication tables, much more have the ability to identify the multiples of 13. Right, so one problem like this is very fitting and appropriate, because nowadays students do not know their multiplication tables, much more to develop or have the capability of identifying multiples of 13, of which 91 is one of them. 93 is obviously not a prime number. We do not have to be sharp on our multiplication table to realize this. Right, both digits are divisible by 3. We can identify another number apart from itself and 1 that may divide into it without leaving a remainder. So we have 93. We have 3 can go into 93. 93 can go into 93. 1 can go into 93. 31 can go into 93. 93 is not a prime number. In 99, the double 9 demonstrates that it is a multiple of 9 and 11. 99 and 93 are the numbers that are quite obviously not prime numbers. These two, they are obviously not prime numbers. Only 97 remains. It is therefore our prime number. The correct answer is option C. I love this problem. What is the exact value of 37.26 divided by 1.8 all over 1000? Exact. That is the number that will bother quite a bit of us. The presence of the word exact might influence candidates to think that they need to go through the entire process of dividing 37.26 by 1.8. However, this is a multiple choice exam and no one will know that in arriving at the correct answer, you did not even make a single stroke of your pen. Therefore, the word says exact, but it does not mean that you need to go and solve the problem exactly in order to arrive at the correct answer. The correct answer is over here already. What more do we want? By considering each option, you will realize that all make use of the same significant figures. Therefore, the actual division process is already done for you. All you need to do is determine the actual size of the number. Now we have 207, 207, 207, 207. Right. What does that tell you? Well, it sure tells me that the answer must have the same significant digit, 207, because it is all in the options. All of the options contain 207. Of course, we have some points, decimal points and decimal places, but we know that the answer is something or some variation of 207. Determining the actual size of the number is really quite simple. We have approximately 37 to divide by 1.8. That quotient is approximately equal to 36 divided by 1.8. Well, we are doing the division without the point on this occasion. 36 divided by 18 is equal to 2. We really should divide by 1.8, which is one decimal place less than 18. The answer should be one decimal place larger than 2. 36 divided by 18 is 2. 36 divided by 1.8, we are dividing a number by another number that is one decimal place less than 18. If we reduce the divisor, then the quotient will be increased. We need to increase the answer by one place of decimal, so we will increase that to 20. 36 divided by 1.8 is equal to 20. After that, we need to divide by 1000, which is reducing the dividend by 3 places of decimal. On the next slide. When dividing by 1000, we are reducing the dividend by 3 places of decimal. In a number that is not accompanied by a decimal fraction, the point is assumed to be at the extreme right. Let us now reduce the fraction by 3 places of decimal. There are only 2 digits in order that a reduction by 3 places of decimal will be possible, we will have to include an additional 0. So, let's go. 1 by 2 reduced by 3 places of decimal. That is what we have. A 0 may be included to the left of the point, 0.020. The correct answer is the one that has the digit 2 in the second decimal place. That number is option B. We have 0.02. Which one in the option has the 2 in the second decimal place? That is option B. That one is correct. We have found the answer without actually dividing 37.26 by 1.8. Do not be tempted by the use of certain or uncertain words. A great percentage of multiple choice problems may be solved by not using any mathematics at all. The examiners are 100% in favor of those who are prepared to use their common sense. The problem that said exact was solved by using an approximation, as we have just seen. We do not have to be taken over by the word exact. We may proceed by using our common sense. If A, B, and C are constants, the equation of the graph could be which one of these? The statement of the problem is one word short. Instead of constants, we should have had positive constants. This is because a positive constant accompanied by a negative sign gives a negative result, and accompanied by a positive sign will give a positive result. If we do not know the sign of the constant, we will not know the sign of the result. Therefore, we need to specify the sign of the constant. However, we may safely assume that the intention of the examiner is that we take all of the constants as positive. All signs will be exactly as they appear. All of the signs here will be exactly as they appear because all of the constants are positive. That will cause those two to be out. Options B and C are out of the question because in the equation of a parabola, if the x squared coefficient is negative, the curve will have an umbrella shape. The curve is U-shaped, therefore, in the equation, the coefficient of x squared has to be positive. So in any quadratic graph that we may draw or sketch, as long as the x squared coefficient is negative, the curve will be umbrella shaped the other way. The one that has the x squared coefficient as positive will have a U shape, like the one that we have right here. Those two are out. The correct answer is option D. We have no coefficient of x in option A. If C is positive, as we assumed previously, that curve will not cross the x-axis. Therefore, since this one crosses the x-axis here and here, we are sure that if this one does not cross the x-axis, then it is also out of the question. It will not cross the x-axis if C is positive, as we assumed before. So if C is positive, as we assumed previously, the curve will not cross the x-axis. If it is negative, the curve would have crossed the x-axis at equal distance on opposite sides of the y-axis. If this C then turns out to be negative, the curve will cross the x-axis. But how? It will cross on the negative side and will cross on the positive side, and in such a way that each x-intercept, or we should say that both x-intercepts will be equal distance from the y-axis. That is if the constant is negative. If it is positive, will not cross the x-axis, as we shall see in a minute. Let us take a look at the reason why, if c is positive, the curve will not cross the x-axis. At each point on the x-axis, the value of y is equal to 0. We are assuming, therefore, we are using this one, that the value of a, the coefficient of x squared, is 1, and that the value of c is 9. We are assuming that the value of y is equal to 0. If y is equal to 0, then this is equal to 0, and we are equating the expression to 0. Here, we have made the x squared coefficient equal to positive 1. C has a positive value. The expression is equated to 0 because y is equal to 0 on the x-axis. A sum of squares does not have real factors. The equation will not have any solution. Therefore, the curve will not cross the x-axis. We may make our point clearer by transposing the constant to the right-hand side. A sum of squares has no real factors. Because we have a sum of squares on the left-hand side, we are sure that this equation will not have any solution, will not have any real solution. Therefore, the curve will not cross the x-axis for a positive value for the constant. There we transpose this positive 9, we get a negative 9 on the right-hand side, then x squared is equal to negative 9. In order to find the value of x, we will have to find the square root of negative 9. The square root of a negative number does not exist. The square root of a negative number does not exist. Just try that on your calculator. The x-intercepts will not exist, and the curve will not cross the x-axis. This curve is crossing the x-axis here and here. The one that we have here will not cross the x-axis if c is positive. Therefore, we are sure that this one is not correct. It will not be correct even if this is negative. What about if in option A the constant were negative, contrary to our earlier assumption? X squared minus 9 is equal to 0. The expression is a difference of two squares that we know to have real factors and may be factorized. Yeah. Or difference of two squares, everybody will jump to the difference of two squares and factorize it. X squared minus 9 is equal to x plus 3x minus 3. We may finish the solution of the equation by transposing this. We have x is equal to positive or negative 3. We are familiar with solving an equation, a quadratic equation, in which the quadratic expression is a difference of two squares. We will have a number, but we will have positive and a negative. The values of x obtained are negative 3 and positive 3. They are equal distance from the y-axis on either side. That is what we expect if the constant c is negative and there is no x value, as we have right here. Okay, now we have a negative value for c, which is not in our original assumption. And what will happen? We get a positive 3 and a negative 3. Therefore, this cannot be correct. If this curve correctly demonstrated this, what would we have? two intercepts as we have them right here. One will be on the negative side and one will be on the positive side, but they will be equal distance from the y-axis. The equation could have been solved by transposing 9. Negative 9, positive 9 on the right hand side, square root of 9, positive or negative 3. It would have still been possible to determine that we would have received two values for x. The square root of 9 is a positive 3 for obvious reasons. But let us take a look at negative 3. Negative 3 is also a square root of 9 because multiplying negative 3 by itself results in positive 9, since negative multiplied by negative is equal to positive. The circumstances would have been the same even if the constant were not a square number. If it were not a square number, the values of x obtained would have been irrational. That is, they would have been square roots with decimals that have an infinite number of decimal places. However, they would have still been equal but of opposite signs and appear at equal distance on opposite sides of the x-axis. The same will be true. They would have been equal distance from the y-axis on either side of the x-axis. However, they would have been irrational numbers. A flaw exists in the problem because let us take a look at what would have happened if all of the constants were positive. Nice. All of the constants are positive. X squared plus 6x plus 8. Everything positive. Let us solve the problem by factorization. What two numbers multiply to give 8 and add to give 6? 2 and 4. X plus 2, x plus 4. Those are the two factors. We may finish the solution of the quadratic equation and we will have x is equal to negative 2 and negative 4. If all of the constants were positive, the two values of x obtained would have been negative. The two x-intercepts would have ended up on the negative side of the x-axis. Option D could not have been a possible representation of the curve, because if all of the constants were positive as in our earlier assumption, the two intercepts would have been negative. Notice what we have. We have this intercept and this intercept. Both of them are on the positive side of the x-axis. While if the constants were positive, we would have them on the negative side. So this problem has a flaw that I hope will be ironed out by the next time we attempt another problem like this. If we want to play it safe and cause the constants to be what we want them to be, the coefficients of x squared will be affected and the curve would have been either U or umbrella shape. Therefore, if the constants were like anything we want it to be, positive or negative, when it is negative or the x squared coefficient is negative, we would have had an umbrella shape. Positive, we would have U shape, and there we will have an ambiguity. The safest route would have been to include in the statement of the problem that all constants are positive and to use a curve with both x-intercepts on the negative side of the x-axis. So we need to fix the sign of the constants. If we fix all of them as positive, then no problem. But this curve would have to cross the x-axis on the negative side on both occasions. So we would have the two x-intercepts on the negative side. And in the statement of the problem, we could have stated that the coefficients are positive. Alternatively, we could just say that only the x squared coefficient is positive, and that would have fixed the curve into a U-shaped position. But if b and c can be of any sign, then we are actually doing the right thing, because if b and c can be of any sign, then the curve could cross anywhere. Both intercepts on the negative sides of the x-axis, or both on the positive side, or one on either side. So if we stated that the x squared coefficient is positive and said nothing about b and c, then I think that would even be a better one than stating that all of the constants are positive and causing the curve to be on the negative side of the x-axis. There we have a point A. The point A is shown on the diagram. What are the coordinates of the image of the point A under a reflection in the y-axis? We are reflecting in the y-axis, and we have two rules. In reflection, the line joining a point to its image must be perpendicular to the mirror line, and the point and its image have to be equal distance from the mirror line. The point is to be reflected in the y-axis. The line joining a point to its image must be perpendicular to the mirror line, which is the y-axis, and the point and its image must be equal distance from the mirror line, which is the y-axis. Since the mirror line is vertical, any line that is perpendicular to it must be horizontal. The point is 4 units to the right of the mirror line. Its image will therefore be 4 units to the left of the mirror line. Here we have the mirror line as the y-axis. It is vertical. The first rule, the line joining the point to its image must be perpendicular to the mirror line. We have no danger there. This line is already perpendicular to the mirror line. Therefore, the image will be located somewhere on this line, on the opposite side of the y-axis. The other rule is that the point and its image have to be equal distance from the mirror line. 1, 2, 3, 4 units. Therefore, the image has to be located 4 units on the other side. 1, 2, 3, 4. There. -4, 3. The correct answer is option A. The line joining the point and its image will be horizontal. There will therefore be no change in the y-ordinate. That is how they do it. They will give you a problem in the CSEC examination, just like this one, a multiple choice, and there is no difficulty solving the problem. If we should take, like what we have just done, the step to go through the entire thing, then we will find that will take a little more time than it really should. If some point is reflected in the y-axis, what will happen? The point will undergo necessarily a horizontal movement. Therefore, the y-ordinate of the point will remain the same. Therefore, all we need to do is look over here and find the one with the y-ordinate that is the same, and we say that that one is actually the image, because 3 is unique here. We do not have any ambiguity by having another 3 here, another positive 3. So we'll actually have to go through the entire process of working it out. We know that the y-ordinate will not change. The one that has the y-ordinate being the same is the correct answer, and we did not have to do the reflection actually. AC and DE are straight lines intersecting at B. Angle DBA is equal to 50 degrees. the measure of angle ABE is what we are trying to determine. ABE. This one is 58. ABE is the one that we need to find. The angle that is given and the one that we seek are angles on a straight line, and we'll add to give 180 degrees. Angles that add to give 180 degrees are called supplementary angles. There we have the straight line. The angle that we need is ABE. It is on the straight line with this angle. Therefore, they are supplementary. They add to give 180 degrees. Let us substitute the one that we know. DBA is 58 degrees. Right. Transposing, we get ABE is equal to 180 degrees minus 58. ABE is 122 degrees. The correct answer is option C. Angles on a straight line are to give 180 degrees. We have one of them. The other one is the rest of 180 degrees, or that which remains when we subtract this one from 180 degrees. We may go to Australia and back in solving the problem. Let us take a look at that on the next slide. Going to Australia and back. We will now consider that at the intersection of two straight lines, opposite angles are equal. CBE is equal to ABD. Right. And we know that these two are equal. The sum of the angles in an entire revolution is 360 degrees. Let us subtract the two angles of 58 degrees each from 360 degrees. Subtract this angle, two of them as a matter of fact, from 360 degrees, and then what is left will be shared between these two. 360 minus 116 is equal to 244 degrees. The other two angles are opposite to each other and are also equal. After subtracting the two angles of 58 degrees from 360 degrees, the remainder will be shared equally between the other two angles. 244 divided by 2 is equal to 122 degrees. That's another way that we could have looked at the problem. This confirms that option C is actually correct. We have chosen to use two principles, and those principles are angles on a straight line have a sum of 180 degrees, and the other one is opposite angles on two intersecting straight lines are equal. We have used that one along with the fact that the angle of an entire revolution is 360 degrees. The diagram shows the angle of depression of a point X from Z. If X is 10 meters from Y, the height YZ in meters is what we are determining. The trig ratio usually associated with angles of elevation and depression is tangent. Because of this fact, we may conclude that the correct answer is option B, tan 30 degrees, because when we are talking about angles of elevation and depression, usually the trig ratio that we consider is tan. However, we may solve the problem actually to verify that we are actually correct. We know that Angles of elevation and depression are alternate angles that are called Z angles and are therefore equal. Like that. So we have another 30 degrees angle right there. The height YZ in meters. This is the height that we are trying to find. Let's go straight ahead. The side YZ that we need to know is opposite to the known angle. Is opposite to the known angle. It is opposite. The known side is adjacent to the known angle. Adjacent. The trig ratio that contains opposite and adjacent is tangent. We may say that we have verified that already. Opposite over adjacent is equal to tan 30. Opposite over adjacent. We have the adjacent is 10 and the opposite is what we need to find. We need to include opposite and adjacent. The tangent trig ratio is what we have to use. And specifically, tangent is opposite over adjacent. We will put the opposite that we do not know, which is YZ, and we will put that over the adjacent that we know to be 10 meters. Then we need to eliminate this 10 by multiplying the equation by 10. We have 10 tan 30 on the right hand side. Transpose the equation by multiplying by 10 on the right hand side. YZ is equal to 10 tan 30. We have verified that the correct answer is actually option B. A ladder 5 meters long is leaning against a vertical wall. The foot of the ladder is 3 meters away from the wall. How far up the wall does the ladder reach? A ladder 5 meters long. There we have the ladder 5 meters long. And what do we know? Is leaning against a vertical wall. There we have the vertical wall against which the ladder is leaning. Anything else? The ladder is 3 meters away from the wall. So we have the 3 meters. The foot of the ladder is 3 meters away from there. We have the 3 meters. And H is the height, or how far up the wall does the ladder reach. We need to determine this height. The first step is to identify that the triangle is actually right angled. The vertical wall and the horizontal ground are perpendicular to each other. We have a right angled triangle with 2 sides given and the other one unknown. Immediately as some candidates see this, they apply Pythagoras theorem. That's what they should do. They are not wrong in applying the theorem. But how? They say what? H is equal to 3 squared plus 5 squared. 9, because 3 squared, 3 times 3 is 9. 5 squared, 5 times 5 is 25. H is equal to the square root of 34. We therefore end up with an answer that requires you to find an irrational square root without a calculator. Furthermore, that is not among the options. An irrational square root, when you work that out, you will get a never-ending decimal fraction. We have rounded numbers here. We are sure that the square root of 34 is not correct. You should have realized that the formula that you used is for the hypotenuse, but the missing side is one of the short ones. Apply the formula appropriately in finding the missing short side. Do not be jumpy. As soon as you see a right angle triangle, one side is missing, you start to add in order to find the missing side. Applying Pythagoras' theorem appropriately this time requires that we square 5 and subtract the square of 3. 25 minus 9, we have the square root of 16, which is equal to 4, and that one is correct. The correct answer is option A. When we have a problem that requires us to apply Pythagoras' theorem, do not just jump at it. Take a look at what is required and progress appropriately. Examiners know mistakes that you are likely to make and sometimes demonstrate this in the way that they set problems. Also, you should be mindful that if what you did was to add the 3 squared to the 5 squared, the result that you would have found would have been greater than 5. Because the result would have been greater than 5, there is no side of a right angled triangle that can be longer than the hypotenuse. You are sure that the answer is incorrect and you need to revisit in order to make wrong right. No side can be longer than the hypotenuse. So when you have the hypotenuse, the correct thing to do is to subtract rather than add. What is the highest common factor of the set of numbers 54, 70, and 90? The highest common factor of a set of numbers is the largest number that may divide into all of them without leaving a remainder. Is it 18? Well, we will now do some refreshers in finding the HCF. We will use repeated division beginning at the smallest prime number that may go into all of the numbers until the entire set of numbers is exhausted. The table form will help us to do this efficiently. There we have the table form and we have the numbers 54, 72, and 90. Two is the smallest prime number that will go into all of those numbers that we need to do. We need to find the smallest prime number that can go into every single one of those numbers. The smallest one that can go into 54 can go into 72 and 90. 2. 54 divided by 2 is 27. 72 divided by 2 is 36. 90 divided by 2 is 45. The number that may divide into all of the results is 3. We may divide each one of these again by 3. Since 3 can go into all of them, we use 3. 3 into 27 is 3. 3 into 36 is 12, and 3 into 45 is 15. Three may be used again. Three into 9 is 3. 3 into 12 is 4. 3 into 15 is 5. The HCF is the product of all of those primes. All of these primes. The HCF is 2 multiplied by 3 multiplied by 3. And that 2, 3 is 6. Multiplied by 3 is 18. The HCF is actually 18, as we have determined before. The correct answer is option B. A student that is sharp may be able to determine that the answer is actually 18 without doing any process. Another way that we could have found the HCF of the numbers would have been by writing down all of the factors of each of them, then identify the largest number among the factors. There we have all of the factors of 54, all of the factors of 72, and all, well, not quite all, but I guess because we have passed what we imagine here, that we did not continue to put the rest of the factors of 90, which is of course 90. So the only one that is missing right here is 90. So all of the factors of 90 with the exception of 90. Let us identify the largest number that is present in the three groups. We have confirmed that the correct answer is in fact option B. In the right angle triangle not drawn to scale, Q is equal to 90 degrees. PQ, that is Q, PQ is 50 centimeters. PR is 130 centimeters. And RQ is X centimeters. We need to find the tangent of PRQ, which is the angle that is located right here. This one. We need to find the tangent of PRQ. The tangent of any angle, and hence of PRQ, is given by tan is equal to opposite over adjacent. So all angles tangent will be given as opposite over adjacent. And the same is true for PRQ. Let us name the sides of the triangle relative to the angle PRQ, because we are determining a trig ratio that is defined on PRQ. So let us name the sides of the triangle relative to PRQ. The hypotenuse is the longest side and it is opposite to the right angle. That does not matter. The relationship between the hypotenuse and the specified angle doesn't really matter. The hypotenuse is always the longest side and it is always opposite to the right angle. So the hypotenuse is the longest side opposite to the right angle. There we have the opposite, the one that is opposite to the specified angle on the other side of or facing the specified angle. This side, 50 centimeters, is the opposite. Here we have opposite. Important to note opposite. The adjacent is the one that is beside the angle, which is x. Substitute the values of the opposite and adjacent in their respective places. The opposite is 50 and the adjacent is x. The correct answer is option A that we have right here. On seeing the original statement of the problem, some students might go straight ahead and calculate the missing one that we have right here, the missing value, which is x. Then at the end, when they consult the options, they realize that they did not have to go through such a problem to find the value of x. I guess sometimes students might be overtaken by their own ability, because it is not impossible for them to find the value of x. They will find it to be 120 centimeters. Because it is not impossible for them to make that calculation in a few seconds, they will go straight ahead and do that. While at the same time, it is not necessary to determine the value of x, because in the option we have x being represented in a few cases. The correct answer is option A, as stated before.